Today's problem was submitted by a viewer, and it says, find the sum to n terms of the series Sn is equal to 1 plus 2x plus 3x squared plus 4x cubed and so on. Okay. So the way it's worded here is I don't particularly like, because it's written in the submission as an infinite series, but it's denoted by Sn and talks about the sum of the first n terms. So let's rewrite this first in something more sensible. So we can see that Sn is the sum, k goes from 1 to n, of k times x to the k minus 1. So again, with n, I don't really understand what we're being asked to do here. If it's trying to ask, if it wants us to write down the infinite series, I mean, recognize that this is the derivative. This is the derivative of something. Let's write the original series S infinity of x. K goes from 1 to infinity of k x to the k minus 1. This is equal to, I'm going to use some pretty harsh notation here. It's equal to that. But if I add a constant, it's the same as that. But this thing on the inside for x between between -1 and 1 is this. Right? This is just a geometric series. So if we take the derivative of this thing, assuming that, you know, sums and so on work out. Okay, so I suppose we could compute this for the first n terms, because well, yeah, it should be possible. I'm going to stop with that. I'm going to go back to the actual question, which is about you know, a finite series. But I'll write this as Sn is the sum, as k goes from 1 to n, of k x to the k minus 1, which is equal to the sum as k goes from 0 to n of x to the k. That's the derivative of that. So this, let's think of this finite geometric series now. I suppose we have an expression for that, right? It's 1 minus x to the n plus 1 over 1 minus x. I think. Let's plug in a couple values of n and make sure this works. When n is equal to 0, I get 1. That's correct. That's probably the only one I need to try. When n is equal to 1, I have 1 minus x squared over 1 minus x, which is equal to 1 plus x. Yeah, this is correct. Okay, so the derivative of this, let me call this f sub n of x. So f prime is that, I mean, we're done technically, but maybe something simplifies. This is equal to Sn of x. I don't really see any nice simplification, but let's write things in terms of powers of x. So we have xn plus 1 in the numerator minus n plus 1 x to the n plus 1 divided by 1 minus x squared. And we should be able to check something must factor in the numerator, because Sn is a polynomial, but I have it written as a rational function. I mean, maybe things don't simplify. Like maybe the only way to write the polynomial is maybe there's no simplification to the polynomial, but by multiplying and dividing by 1 minus x squared, the numerator becomes simplified. So I'll just say that Sn is equal to this. I'm noticing now there's a follow-up question. So I didn't notice this follow-up question before. The follow-up question says, prove that the sum to infinity of the series is the following. S infinity is equal to 1 over 1 minus x squared. Now, this requires, of course, from my original observation up here, it requires this only converges if x is less than 1 in absolute value. But, I mean, we're basically done, right? If x is less than 1 in absolute value, then as we take a limit as n goes to infinity, these both go to 0. So that's also essentially done right away. I'm not sure if this is exactly the expression that's being, that was intended to be arrived at, but it's the most sensible thing that I can make from the way that this is written. Yeah, thanks for watching.